I'm going to talk about the analysis of the mass transfer of toluene stored as a raw material in a TNT production plant tour. First, I'm going to describe the problem. In a TNT production plant, there is liquid toluene in a storage silo, which is used as a raw material to produce this compound. Accidentally, the storage silo was left open, and after some time, the workers noticed that the level of the liquid toluene of the silo decreased from 1.5 meters to 1.475 meters. So it is necessary to calculate the time in which the toluene was exposed to the air, and at the same time, we need to obtain the emission rate of the toluene vapor from the silo to the air at 30 degrees and 1 atmosphere. The capacity of the silo is 5 cubic meters, considering a height of 4 meters and a diameter of 1.3 meters. To start solving the problem, we need to know about the assumptions and the boundary conditions. The assumptions is that it's a pseudo-steady state, non-homogeneous reaction, diffusivity and set, cylindrical coordinate system, DAB, temperature and pressure is constant, and the air is stagnant. This means that NB is equal to 0. The boundary conditions is that JA2 is equal to 0 at set 2 is 4 meters. JB2 is equal to 1 at say a set 2 is 4 meters. Set 1 is 1.5 at time is 0, and set 2 1.475 at time 1. Volume 1 is 1.9 cubic meters at time 0, and volume 2 is 1.8 cubic meters at time 1. Now we need to know the approach tools that we use to solve the problem that is going to appear here. That is the Fick's law, so the steady state, the equation to get the time, and the equation to get the GB logarithm. Also, we need to know some data like density, molecular weight, pressure, vapor pressure, and it's also going to appear here. Also, we need to know some data of the tank, like the volume, like the height, like the diameter, and the area. Now it's time to solve the problem. First, we need to know the concentration, so we use the ideal gas law. We need to know the pressure, the air constant, and the temperature, and they are going to appear here. Also, we need to know the diffusivity. We have a diffusivity that is at 298 Kelvin, but we need this diffusivity at 303.15 Kelvin. So we need to do a temperature correction with this diffusivity, and the formula is going to appear here. Now we have to calculate the fractions. J1 is calculated by the vapor pressure divided by the total pressure. The total pressure that we are considering is 1 atmosphere. JA2 is considered 0 because of the air. JB1 is 1 minus JA1, and JB2 is 1. After that, we need to get the JB logarithm that is going to appear here, that also is with the fractions that we had also calculated. Now we are going to get the flux. The flux is obtained by the multiplication of the concentration with the diffusivity constant and the JA1 minus JA2 divided into delta Z2 minus delta Z1 multiplied by GB logarithm. Here I'm going to put how to do it. After that, we need to know the WA. This is multiplied by the flux, the NAC, times the area. And here I'm going to put it again. Now we can get to start to calculate the time. First, we need to know the volume loss. Here I'm going to put the formulas, and we need to know the density, the molar density. And here I'm going to put the formulas again. Once you get these values, finally we can calculate the time. The time is expressed by the volume loss times the density molar divided by the NaZ times the area. This is WA that we have also calculated. And here is the time that we get is 3.79 days. Here I'm showing a table with the final results, that all the values that we calculate, and we can also appreciate the comparison of the limit rate emission and the rate that we calculate. The limit rate emission is 35.61 kilograms per day, and the rate emission that we calculate is 7.05 kilograms per day. So this means that we do not pass the limit permissible at day. In conclusion, toluene emission rate that we calculate is lower than the established, so this not present a risk for the environmental and also not present a risk from the workers. Also, it is necessary for the toluene to get a higher temperature conditions so that there can be a greater emission of toluene vapor. And finally, it is important to calculate the emissions generated to avoid environmental and personal risk. Thank you.